All right, and welcome back. This is video number 3. I says video number 4, but it really is video number 3. I adjusted things. Video number 3 for section 5.6. We're going to put it all together for rational functions. So what are some things we need to know about rational functions? We need to make sure we check for any wholes. That's where the numerator and the denominator both equal to 0. We need to check the domain and look for the vertical asymptotes. We need to find all the intercepts. We need to look at the horizontal asymptotes. We need to think about what's going on with the behavior, and then we can graph it. All right, so let's get started with this first example. Let's start by checking for any wholes. Well, there's not going to be any wholes in this function because the numerator and the denominator don't share any factors. So we can say no wholes. No wholes because there's no common factors in the numerator and denominator. Let's find the domain, okay? This is where the denominator equals 0, and this one's nice and factored for you. So we have x equal to 7 is excluded from the domain, and also x equal to negative 8. So those are my vertical asymptotes. And the domain is going to be equal to minus infinity up to minus 8, union from minus 8 to 7, excluding those endpoints, and 7 to infinity. All right, let's find all our intercepts. Well, we find our horizontal intercepts by setting the numerator equal to 0. And again, this one's already nicely factored for you, so we can just practice our rational function skills. That's going to be at x equal to 3 and x equal to negative 2. So those are our horizontal intercepts, 3, 0, and negative 2, 0. And our vertical intercepts is by finding, so those are our horizontal intercepts. And let's find our vertical intercepts are by plugging in the function value at 0. So f of 0 gives us a vertical intercept. It's only ever going to be 1. Right? 0 minus 3, 0 plus 2 over 4 times 0 minus 7, 0 plus 8. I might need a calculator for this one. Equals 3 times negative 3 times 2 over 4 times negative 7 times 8. So the numerator is 3 times negative 3 is negative 9, negative 18 over, I don't think I know what 28 times 8 is, to be honest with you. Grab my calculator. 4 times negative 7 times 8 is negative 224. All right, does that reduce? Yeah, let's divide everybody by 2. So that gives me, oh, well, they're positive now. And then these guys can cancel. So we get 9 over 112. Let's see. It's not divisible by 3, is it? Nope, that's it. That's as good as it's going to get. So the vertical intercept is 0, 9 over 112. I'm not going to put that as a fraction because it doesn't look very nice as a fraction. I'd have to round. And then, what else was I supposed to do? Let's look at our horizontal asymptotes. Well, this is a little bit tricky because you're supposed to look at the degree, right? The degree of the numerator and the degree of the denominator to figure out the horizontal asymptote. So I'm actually gonna, I don't have enough space here. I'm gonna do that one up here. So to figure out number 4, sorry for moving all over the place here, we're gonna have to do some foiling, all right? Let's FOIL out the numerator and FOIL out the denominator here. And so we're gonna go 3, and let's FOIL these guys. So that's x squared plus 2x, x squared plus 2x minus 3x minus 6 for the numerator. And let's do the denominator too. 4 x squared plus 8x minus 7x minus 56 equals, and that's going to be minus x in here, and that's going to be plus x. So we get 3x squared minus 3x 3x squared minus 3x minus 18 over 4x squared plus 4x, 56 times 4, I don't know, minus 224. So we did all that work, but we actually probably didn't have to, but it was good practice anyway, and it was good to make sure that we understand what's going on here. Let me switch to a different color. So why am I saying we probably didn't have to? Well, we could see by looking that these are two linear terms multiplied together, so we should have known that when we multiplied them both, we would end up with an x squared term. And since the 1s were all coefficients on all my x's in this problem, my leading coefficients are going to be 3 over 4. So the degree of the top is equal to the degree of the bottom. So that means that the horizontal asymptote is y equals the ratio of the leading coefficients. Y equals 3/4 is our horizontal asymptote. So what does that mean for our end behavior? It means as x goes to infinity, the function is going to go to 3/4. And as x goes to minus infinity, the function is going to go to 3/4 for our end behavior. So both times the function is going to go to this horizontal asymptote. All right, so what we're going to do now is we're going to go to Desmos and look at a graph of this guy. All right, here we are in Desmos, and let's go ahead and graph this function. F of x equals, parenthesis for the numerator, 3x minus 3, x plus 2, and my numerator parenthesis divided by, oops, just a 4, 4, x minus 7, x plus 8. All right, looking pretty good. I don't like the red so much. Let's switch to like green or something. Okay. All right, let's zoom out. All right, let's see if we can talk about all the things that we found or didn't find. Well, we didn't find any holes, so that's good. They're hard to see in Desmos anyway. But we do have some vertical asymptotes. One of them was x equal to 7 and x equal to negative 8 was the other one. Let's make the vertical asymptotes blue so we can keep organized here. Oh, we should do dashed lines. Isn't that great? Oh yeah, totally do dashed lines. I like that. There we go. So there are our two vertical asymptotes. Looking good, not crossing. So we feel really good about this graph. We can see that it doesn't cross that. We have two horizontal intercepts. We had 3, 0, and so that looks good, 3, 0, and the other one was negative 2, 0. And sure enough, that looks good too. We checked that on our graph. So we have our two horizontal intercepts. Our vertical intercept was 0, 9/12, which is a little bit hard to see, but I think if we put in 0, 9 over, 112, we can label that guy. You can see that that looks pretty good right on the graph. And finally, let's go ahead and put in our horizontal asymptote, which we got was y equal to 3/4. And let's go ahead and make that look asymptote by making it dashed and maybe red so we can tell the difference between the two. And yeah, as we scroll out, we can see that this graph is getting really close to 0. And if we trace along even, we can see it's getting really close to 0, but it's not crossing in both ways. So those are really all the pieces of our rational function that we have put together. And there's a lot of little pieces to this, but it's really nice to go through, figure them out algebraically, and then use Desmos to verify everything that you found. All right, the next function that we're going to talk about, I'm going to actually graph first. And I'm going to let you guys go find all this stuff algebraically. So let's go ahead and I'm going to give it to you right now. So let's get a new graph. New blank graph. And the one I want you guys, I'm going to graph it first, and then I want you to go ahead and find all those things. This is g of x equals x squared minus 5x. Oops, I didn't mean to hit enter. I'm going to hit divided by x cubed minus 3x squared minus 4x. This is a little bit more complicated, but let's look at a graph of it first and see if we can point out some things that are going to help us direct our algebra here. So let's make it green, I think. All right, so we're looking at this. There's a zoom way out, right? Maybe it is 0. Actually, as I look now, I think it is 0. It just took forever to get there over here. And as we zoom back in, we can see that I definitely see some places it's crossing the x-axis. So there's definitely some of that going on there. And it's definitely got a vertical intercept. I can see where it crosses the vertical axis right here. I can see some vertical asymptotic behavior here and here, so I'm expecting to find some of those. So what I want you to do now is pause the video, use this function and find all 6 steps, and I'm going to go over it with you. All right, how did it go? Hopefully it went okay. So before we start finding all these things, I'm going to save myself a little bit of pain and suffering. I'm going to go ahead and just try and factor the numerator and denominator because I think that really helps in some ways. So one thing I'm going to do, and you don't have to do this, but I'm going to, is I'm going to go ahead and factor the numerator and denominator. All right, so g of x equals, well, I'm looking at the numerator. I can see it both has a common term of x. I'm going to factor out an x and do x times x minus 5. And if I look at the denominator, it also has a common term of x. I'm going to factor that x out. That's looking interesting. X squared minus 3x minus 4 when I factor out an x. Now, can we factor that more? Yeah, I think we can. Not the numerator. The numerator is x over x minus 5. The denominator is x times x. Let's see, multiply to negative 4 out of negative 3. X minus 4x plus 1. X squared plus x minus 4x minus 4. That looks good. All right, why did I say like that? I was like, oh dear, what's going on with my x? Well, that's a common factor. That was the very first thing to look for, is a hole. And it looks like we might have a hole in our function at 0, 0. Yes, and if I go back to Desmos, which you can't see because I'm on a different screen, if you actually go to 0 on your Desmos, look at it right now, it comes up 0, comma undefined. So number 1, we found a hole at x equal to 0. Okay. All right, what's the next thing we're going to find? The domain, right? Is that number 2? I always forget what order I put these things in. Number 2 is the domain. Domain of vertical asymptotes. Well, we know 0 is not in the domain. What else isn't in the domain? Well, we have x equal to 4 is going to make x minus 4 0. And we have x equal to negative 1 is going to make x plus 1 equal to 0. So those guys are my vertical asymptotes, right? And so my domain is going to be equal to minus infinity up to negative 1, union negative 1 to 0, union 0 to 4, union 4 to infinity. Basically everybody but 4, negative 1, and 0. All real numbers except 4, negative 1, and 0. All right, what's the next thing that I want to find? Probably my horizontal intercepts. Well, that's going to be where x minus 5 equals 0. So that's at x equal to 5. So my horizontal intercept is 5, 0. And remember, 0, 0 is a hole, so we don't want to include that as a horizontal intercept since it's really not even in the domain. And let's find the vertical intercept. That should be interesting. Well, we're going to put, oh no, g of 0. What does that mean? Well, 0 isn't in the domain of the function, right? We excluded 0. So there is no vertical intercept because this does not exist, right? We can't plug 0 into the function. It's not in the domain. So that means no vertical intercept. All right, horizontal intercept, vertical intercept. Well, what do we need to do now? It's number 5. Oh, I think we're on number 4, actually. All intercepts was number 3. Number 4 is, yeah, that was number 3. Number 4 is horizontal asymptote. All right, let's look at the degrees here. Well, looking at the original function, the degree of the numerator is 2. The degree of the denominator is 3. So the numerator is less than the denominator. So that means that y equal to 0 is my horizontal asymptote based on my rule. And finally, end behavior. Yep, end behavior, because we've already done the graph, right? We started with the graph this time. So the end behavior is that as x goes to infinity, my function approaches my horizontal asymptote, g of x goes to 0. And as x goes to minus infinity, g of x goes to 0. They both approach the horizontal asymptote as x goes to infinity. All right, excellent.